So welcome to Cramer's rule. This is 11.3 and it's an introduction to Cramer's rule. It's another way to solve equations, although like other situations, they have lots of applications. And so Cramer's rule is pretty neat. It's using determinants, something that you used when you found the cross product, in order to come up with solutions to the equation. So it's kind of funny because they're teaching you how to do determinants here, but yet they expected you to do it back in chapter 9 and as you found the cross product. So I don't know how much explanation needs to be given of how to find a determinant, but here's what Cramer figured out. He figured out if you had the equations ax plus by is equal to s and cx plus dy was equal to t, then you could find the you could find the solutions by a determinant process. And so what Cramer figured out is that, well, in order for this to work, you would need this determinant, which he calls D, capital D, A, B, C, D. You would need that to not be zero. So as long as that's not zero, then Cramer's rule will help you. When it is zero, you would have to use another technique. And what Cramer figured out is that if you use that determinant with both of these, now he has a d sub x. Now what d sub x does is it subs out the x with the two constants that it's equal to. And dy would take and sub out in that d the y's for s and t. And so what he found is that if you want to know the solution for x, it's the determinant with x replaced over the d, and y would be equal to dy over d. And this naturally extends to more variables, and that's where it gets its power, is that it can definitely help us out in different situations. But this is what we're going to be dealing with. We're going to be dealing with finding determinants and using them to solve equations. And so if it's a 2 by 2 determinant, it's pretty easy, right? Hopefully you remember. So let's suppose we had 2, 3, 4, 5 written in that order. The determinant is simply 2 times 5 minus 3 times 4, right? This main diagonal here minus this diagonal here. So you'd have 10 minus 12 for negative 2. That would be the determinant. So that's what we're going to be doing each time. And we have a setup like this, setting up those determinants and being able to use them to solve our equations.